it carries almost 10% weightage, wherein I'm going to talk about moving charge and magnetism. And in this part of the session, I'll primarily be covering the impact of the moving charges and how is magnetic field generated due to charges in motion. So primarily current is the major reason, or current is the main cause of magnetic field being generated around us. And we're going to discuss the mathematical relations for it and also going to do questions on that. So let's get started. I'll be talking about magnetic field due to a current carrying conductor. Then we'll move on to Ampere's law. Then we'll discuss about magnetic force on a moving charge. You all know that. Magnetic force between parallel wires, the torque due to the magnetic field, and the torque experienced by a charge placed in a magnetic field, and that is primarily what we're going to do in today's session. तो मैं कुछ आपको important formulae बताऊंगा, but majorly हम उसके बाद question solve करेंगे. Right. So let me get started. So first we look at the Biot-Savart law. Biot-Savart law क्या कहती है कि अगर कहीं पर भी एक current carrying conductor है like this is the current carrying conductor carrying current in this direction, and we are supposed to find the magnetic field at a point P. So हम पूरे वायर की वजह से magnetic field एक बार में नहीं निकाल सकते, तो हम वायर को split करेंगे into small elements. Let's say this is an element of length ds or dl, normally written in books as dl, or the position of this element from point P is denoted by this vector. So point P पर अगर मुझे magnetic field निकालनी है, so R denotes the position of the point from this element. So the magnetic field due to this small element is given by mu naught by 4 pi, which is a constant, I dl cross R or ds cross R divided by R cube. So ये फॉर्मूला हमारा निकल के आता है फिर mu naught by 4 pi I ds sin theta divided by R square in magnitude, and its direction vector is in the direction of ds cross R. So that's how we find the direction of the magnetic field. तो इस केस में अगर हम देखें तो ds vector is in the direction of the current, R vector इधर है, तो ds से R की तरफ fingers को curl करेंगे, तो magnetic field at this point would be in the outward direction. So this is how the magnetic field would be denoted by the dot. Dot का मतलब होता है outward direction, cross का मतलब होता है inward direction. So this is the basic of the Biot-Savart law. Important जो इसमें important है वो है Ampere's law, और Ampere's law के basis पे बहुत चीजें हमारी simplify होती हैं. So Ampere's law is very similar to Gauss law that you've studied in electrostatics, पर यहाँ पर हम किसी भी current carrying wire के around एक loop लेते हैं, और उस loop पर अगर हम closed line integral करते हैं, तो closed का मतलब हम ऐसे sign बनाते हैं integration sign के ऊपर, और L लिखने का मतलब line integral of B dot dl. So on an arbitrary loop that you've chosen, you look at the direction of B at every place along dl. So B dot dl kiya, this is always equal to mu naught times the current elements enclosed in the loop. So B dot dl is equal to mu naught I enclosed. This is what we call as Ampere's law, and this law is used invariably at a lot of places in the application or practical application of magnetic field. So now if I move on to a long straight conductor and I use the Ampere's law. So let's say I choose a loop of radius small r. मेरे को अगर बोला जाता है कुछ भी एक point लिया जाता है point P which is at a distance small r from the wire, तो मैं small r radius का एक circular loop बनाऊंगा. इस पूरे सर्कुलर लूप में मैं b डॉट dl का क्लोज इंटीग्रल करूंगा जो आएगा b into 2 pi r, because b यहाँ पर along the loop ही है at every place, it is tangent to the loop, is equal to mu naught into I enclosed. So I enclosed जो हो गया हमारा वो इस वायर का करंट हो गया, तो ये आगे b is equal to mu naught I into 2 pi upon 2 pi r. This is the magnetic field due to this particular current carrying wire at a distance r. अगर बच्चों कभी भी दो वायर्स दी हैं, लेट्स से एक वायर है which is carrying a current I1, एक और वायर है which is carrying a current I2. So एक और wire carrying a current I2 here in this direction. So इसमें current हो गया I2. So both the currents are in the opposite direction. And now if I'm supposed to find the magnetic field at some distance small r from here. So first I draw a loop at the small r of smaller radius ऐसे करके, और फिर मैं इस पे जब करंट एम्पियर्स लॉ अप्लाई करूंगा तो मुझे मिलेगा B into 2 pi r. I'm assuming that r is very large compared to the separation between the two wires is equal to mu naught times the current enclosed में एक करंट को अगर पॉजिटिव लूंगा तो दूसरे को नेगेटिव लूंगा. So that is the important point. So B is equal to mu naught I1 minus I2 divided by 2 pi r. ठीक है? So this is how it is supposed to be done. Something which you all know, but I thought I'll reiterate. अब अगर हम एम्पियर्स लॉ को यूज करके ही मैग्नेटिक फील्ड इनसाइड अ कंडक्टर देख रहे हैं, सो द इंटायर कंडक्टर इज कैरिंग करंट. So let's say the wire looks something like this. It's a cylindrical wire. अगर हमारे पास ये कैसे cylindrical wire है, इस पूरे वायर के वॉल्यूम में करंट फ्लो कर रहा है. सो करंट इस पूरे वायर के वॉल्यूम में फ्लो कर रहा है. इस तरह से करंट फ्लो कर रहा है पूरे वायर के वॉल्यूम में. और मेरे को बोला जाता है एट सम पॉइंट स्मॉल आर इनसाइड एंड एट कैपिटल आर इक्वल टू द रेडियस मुझे मैग्नेटिक फील्ड निकालनी है. तो सबसे पहली चीज, जब मैं एट स्मॉल आर देख रहा हूं तो B डॉट dl करूंगा विच विल बी इक्वल टू B into 2 pi small r is equal to mu naught times the current enclosed. Now how do I find the current enclosed here? So to find the current enclosed, what do? We take a small area inside it of radius small r. ठीक है बच्चों, स्मॉल आर रेडियस का जितनी रेडियस के रीजन में मुझे देखनी है मैग्नेटिक फील्ड जिसकी वजह से देखनी है, सो मैंने सिर्फ उसके उतने क्रॉस सेक्शन को लिया. नाउ I current flows through the entire cross section which is equal to pi into capital R square. I want to find a current I dash which flows through pi into small r square. So from here I get I dash, which is the current enclosed, which can also be written as the current enclosed is equal to I small r square upon capital R square. So if this is the value of I enclosed that I get, so then B is equal to, अब मैं इसके जब मैंने इंटीग्रेशन किया तो मेरे को मिला B into 2 pi small r is equal to mu naught times I small r square upon capital R square. So from here we get B as mu naught I upon 2 pi r square multiplied with small r. That's the answer. Right? So I think all of you understood. In case you want to take a minute to note it down, please do that. So similarly, if I have to find the magnetic field at a periphery, small r will be equal to capital R, and on putting the value of small r as capital R, we will get the same value that we've been getting for a wire, which is equal to mu naught I by 2 pi capital R. So simple and easy to handle. ठीक है बच्चों? Now let's look at the magnetic field due to a circular loop on the axis. So अगर axis पे मुझे देखना है तो axis पे let's say from the center we are finding the magnetic field at a distance x. तो सबसे पहले मैग्नेटिक फील्ड का डायरेक्शन निकालेंगे. डायरेक्शन निकालने के लिए आप लूप में डायरेक्शन ऑफ करंट कीजिए. सो सपोज करते हैं लूप ऐसे है और डायरेक्शन ऑफ करंट इस तरह से है, तो मैग्नेटिक फील्ड टू द राइट आएगी। अगर करंट ऑपोजिट डायरेक्शन में हो गया तो मैग्नेटिक फील्ड टू द लेफ्ट आएगी। सो इस केस में एट पॉइंट P आई कैन से दैट द मैग्नेटिक फील्ड दैट वी आर ट्राइंग टू कैलकुलेट एट अ डिस्टेंस x इज इन दिस पर्टिकुलर डायरेक्शन, राइट। सो इस मैग्नेटिक फील्ड का फॉर्मूला होता है म्यू नॉट आई आर स्क्वायर। तो डायरेक्शन मैंने दिखा दिया आपको। इफ यू वांट टू राइट इट इन द वेक्टर फॉर्म देन यू विल राइट आई कैप हियर। So mu naught I small r square, where small r is the radius of the loop, right, upon twice r square plus x square to the power 3 by 2, right. So b as a function of x is equal to mu naught I small r square upon 2 r square plus x square to the power 3 by 2 I cap. Now if I have to find b at the center, so B at the center. So अगर center की बात कर रहा हूं तो it means simply means I'm writing it so that you understand. It means x is equal to 0. So put x equal to 0 there and you get it as B is equal to, I'm calling it B naught because I'm calling it at the center, is equal to mu naught I upon twice small r. So this is the value of B naught at the center of the loop. So ये formula you need to remember, क्योंकि इस फॉर्मूले का यूज आ जाता है और इसलिए हमें पता होना चाहिए। Now if I have to find the magnetic field due to a solenoid or a circular arc का भी अगर देखना है मुझे, सो दोनों की हमने बात की है। यहाँ पहले सर्कुलर आर्क की बात करते हैं। अगर सर्कुलर आर्क है तो आप जानते हो पूरी आर्क की लेंथ होती है 2 पाई आर, उसकी वजह से मैग्नेटिक फील्ड होती थी म्यू नॉट आई अपॉन 2 आर। और अगर मेरे पास एक फाई एंगल सबटेंड करती हुई आर्क है तो उसका फॉर्मूला होता है म्यू नॉट आई फाई अपॉन 4 पाई आर। In this only, if you have to find the magnetic field due to the complete loop, then if phi is equal to 2 pi, you know B will come out to be mu naught I by 2r. तो आप ये याद रखिएगा formula. This is again something that you have to remember, and that is why I'm writing it for you. Now, if I have to find the magnetic field due to a solenoid, all of you have seen a solenoid. So जब हम सोलेनॉइड की बात करते हैं तो वी ऑलवेज टॉक अबाउट अ लॉन्ग सोलेनॉइड। लॉन्ग सोलेनॉइड का मतलब है द लेंथ ऑफ द सोलेनॉइड इज वेरी वेरी लार्ज कंपेयर टू द रेडियस। सो स्मॉल आर के कंपैरिजन में एल बहुत बड़ी है, तो एल इज वेरी वेरी लार्ज कंपेयर टू स्मॉल आर और द रेडियस ऑफ ईच कॉइल ऑफ द सोलेनॉइड। देन वी कैन से दैट B is equal to mu naught Ni. What is N? N is the number of turns per unit length. So एक unit length में solenoid के कितने number of turns हैं, that is small n, and total number of turns let's say is capital N. So small n is equal to capital N by capital L, right? तो ये एक और important formula है जिसे आपको याद रखना है। So हमने solenoid की magnetic field की बात कर ली। We've talked about magnetic field due to a complete circular loop at the center or an arc of a circle. We've talked about the magnetic field due to a circular loop on the axis. So all these things have been discussed here. अब हम आते हैं force on a moving charge पे। If you have to find the force on a moving charge, so let's say the moving charge enters a magnetic field B, which is in this direction, and it enters with a speed v. So the force experience is always equal to Q into V cross P. V cross P, so direction निकालना है force का, तो force is in the direction of the, it is perpendicular to the plane containing vector V and vector B. So vector V और vector B वाला plane बनाया, उसके perpendicular आपने F vector बना दिया, force vector. So F is equal to Q V cross P और F is equal to Q V B sin theta. Simple है, ठीक है जी। नेक्स्ट हम बात करते हैं कि if V is perpendicular to B, what will be the motion like? So here the speed V is perpendicular to the magnetic field B, and we're trying to find the force. So हम जानते हैं F will be equal to QVB sin 90, which is equal to QVB. And we know that this QVB force is the one that is providing the necessary centripetal acceleration. So F is equal to MAC. So QVB is equal to MAC can be written as V square by R. So from here we get R is equal to MV by QB, which is written. I hope all of you understood. So this is how the radius of the circular turn is found. और फोर्स का डायरेक्शन निकालने के लिए आपने किया V ऐसे है, B अंदर की तरफ है तो V क्रॉस B ऊपर की तरफ आया, चार्ज घूम के थोड़ा इधर पहुंच गया, V ऐसे हो गई, B अभी भी अंदर की तरफ है तो फोर्स ऐसे आया. तो फोर्स is always acting towards a common point which is the center, and hence the motion is circular. Right. Very important to note that the radius is dependent on the momentum and Q into B. Up. If we're supposed to find the time taken by the particle to complete one circular rotation, we know that time period is equal to 2 pi by omega, or time period is equal to the distance covered 2 pi r by V for one particular circular turn. So we know R is equal to MV by QB. So R by V is equal to M by QB. So T is equal to 2 pi R by V, which is equal to 2 pi M by QP. And hence this is the answer that you get at the end. ठीक है, so simple, formulae, straight and quite easy to calculate. Right? बच्चों याद रखना, here time period is independent of V, it is independent of V and R. ये ध्यान रखने वाली बात है. Now what will happen if there are two wires that are close to each other and they're carrying currents? So whenever there are two wires that carry current, right? So हम ऐसे देख लेते हैं. Easier to look at it this way कि मेरे पास ये एक वायर है, ये दूसरा वायर है. Now what do I want to find? I want to find the force per unit length on each wire. So let's say this wire carries a current I1 and this wire carries a current I2. And the separation between the two wires is small d. So if I have to find the force on this particular wire, wire 2 because of wire 1, so I'll say that force on wire 2 is equal to I2 dl cross B. And B will be due to wire number 1. So wire 1 की वजह से magnetic field यहाँ पे अंदर की तरफ होगी. This is the magnetic field due to wire 1. B1 will be equal to mu naught I1 by 2 pi d. So F2 is equal to I2 dl mu naught I1 upon 2 pi d. So force per unit length, which is F2 by dl here, which is on a small element dl, is equal to mu naught I1 I2 by 2 pi d. Similarly, if you try to find the force on the other wire, it will again come out to be the same in magnitude, but direction की बात करते हैं. Direction है dl cross B1. अब dl, इसका dl वेक्टर जो है वो अपवर्ड डायरेक्शन में है, क्योंकि करंट के डायरेक्शन में लेते हैं dl. dl अपवर्ड B इनवर्ट, तो ये फोर्स कैसे आया? इस तरफ आया. So F2 is this way. F1 on this wire will also be this way. So if the wires carry current in the same direction, they'll always attract, and this will be the force per unit length. And if they carry current in opposite direction, they'll repel each other. So if the currents are in the same direction, wires attract. If the currents are in the opposite direction, wires repel. So here it is, if the currents are in the same direction, the wires will attract. And if they're in the opposite direction, the wires will repel. So this is the formula for the force per unit length. यहाँ पर हमें force per unit length देखना होता है normally. Now, if there's a rectangular coil placed in a magnetic field, the rectangular coil always experiences a torque, and that torque is given by M cross B. M क्या होता है यहाँ पे? This is the magnetic moment of a loop. Magnetic moment of the loop, and B is the external magnetic field. External magnetic field. So अब अगर यहाँ पर हम देखें M कैसे निकाला जाता है बच्चों, अगर हमारे पास एक लूप है, whatever may be the shape of the loop, इस लूप का अगर करंट ऐसे है, this is I, so we try to find M, magnetic moment, which is equal to IA in terms of magnitude, and direction of magnetic moment is always, if you curl the fingers in the direction of current, the thumb gives you the direction of magnetic moment. So इस case में magnetic moment, इस particular loop का magnetic moment आएगा K cap. So magnetic moment will always be perpendicular to the plane in which the loop is kept, and it will depend on the direction of current. तो अगर direction of current उल्टा कर दूंगा तो same magnetic moment आएगा, but होगा क्या कि हमारा vector sign उसका opposite हो जाएगा, so it will be in the minus K cap direction. ठीक है बच्चों, so M को हम अगर n number of turns हैं तो M can be written as NIA into B sin theta. This is how we will write it. So you remember that whenever a complete loop is placed in a magnetic field, the net force will always be 0, but it will experience a net torque. ठीक है? So with this we come to questions now. Please read the first question and try to answer it in a minute. I'll give you a minute to answer. So बच्चों, question पढ़ा आपने. A straight line thin conductor is bent as shown in the figure and carries a current I amperes and has a radius small r meters. The magnetic induction at the center of the semicircular arc is. So when I'm looking at the semicircular arc, first thing is that the current has to be taken in this particular direction. So current ऐसे है, so because it's coming this way in the straight part. Now the straight parts will have zero magnetic field produced here due to the straight parts, because the point lies along the straight wire, right? So if any point lies on the straight wire or along the line of the straight wire, it does not produce a magnetic field there. So the magnetic field will only be due to the half loop that we have. And we know that due to the full circular loop, the magnetic field is mu I by 4r 2r. So abhi ho jayega mu naught I by 4r. And the direction, keep your fingers in the direction of the current. The thumb gives the direction of magnetic field. So please direction zarur likhna hai. And direction is minus K cap. So this is how you'll write the magnetic field vector as. Pretty simple, 1 marker, 2 marker, that's how it is, and easy to do. अगले question पे आते हैं. A long wire carries a steady current. It is bent into a circle of 1 turn. Circle of 1 turn. And the magnetic field at the center of the coil is B. So if it has just 1 turn, the magnetic field at the center is B. It is then bent into circular loop of small n turns. So if you bend it into circular loops of small n turns, so this is how the small n turns look like. What will be the magnetic field at the center now? So you have to find B dash in terms of B. So B dash has to be something into B. So that is what we're looking at. So thoda sa socho bachcho, give it a trial for a couple of minutes and then we'll do it. सो बच्चों यहाँ पर कैसे करेंगे? सबसे पहली चीज, the length of the or the perimeter of the larger circle, which is 2 pi capital R, is equal to the total perimeter of the smaller circles put together. So this is equal to n times 2 pi small r. So this helps me find the value of small r in terms of capital R. So small r is equal to capital R by n. So this is how the radius would change. Now magnetic field due to one single loop will be mu naught I by twice smaller. That will be the magnetic field due to a single small loop. And if I has B dash, it will be equal to mu naught I by 2r into small n. Now small r can be replaced by capital R by n. So I get mu naught I n upon 2 capital R by n. So this becomes mu naught I n square by twice capital R. And this mu naught I by twice capital R is the magnetic field of the larger loop. So can I say B dash is equal to n square times B? That's what I get finally. Right? So this is how we're going to approach such a question. तो समझ में आ जाना चाहिए यहाँ से, हो और क्लैरिटी पूरी होनी चाहिए कि किस तरह से इस क्वेश्चन को हम अप्रोच करने वाले हैं. Simple. First thing is, as I've always been saying from class 1, diagram. Diagram is the key. When you draw the diagram, you actually visualize and then rest is mathematical formula. इस क्वेश्चन पे आते हैं. Again, let's try to devote 2 minutes to it before we move ahead. So read, try, then I discuss. Particular question. A stream of electrons is fired into a chamber as shown. The magnetic field B is the magnetic field is B and is directed normally to the plane of the slide. Taking the charge and mass of electron to be small e and small m respectively, determine the velocity so that they can be detected by the detector. So यहाँ पर अगर यहाँ से beams को eject किया है और यहाँ पे detect कर रहे हैं, it means they'll follow a circular path and the radius of the circular path is equal to half of the length between these 2 points. So R is equal to L by 2. So what do we need to find? We need to find the velocity. So हम जानते हैं R is equal to mv by qb. So instead of R, can I say L by 2 is equal to mv upon eb. ठीक है. So V हो गई अपनी. What is V equal to? From here you can see it is equal to E B L by 2m. That's it. It is done. It's done with ease. So I hope there's been no doubt here. It is equal to EBL by 2m. Simple. ठीक है बच्चों. अब यहां पर एक और इंपॉर्टेंट चीज, बच्चों जब भी हम कभी डायरेक्शन देखते हैं फोर्स का, तो फोर्स का डायरेक्शन देखने के लिए हम करते हैं V क्रॉस B. Now V is this way and B is inside, so फोर्स ऊपर की तरफ आ रहा है, बट ये इलेक्ट्रॉन है. जो हमारा V क्रॉस B से डायरेक्शन ऑफ फोर्स मिलता है, दैट इज फोर्स ऑन अ पॉजिटिव चार्ज. Here you have an electron moving, so electron पे the force would be in a direction opposite to the direction that you get from V cross B. So इसलिए फोर्स इस तरफ आएगा, इसीलिए ये ऐसा सर्कुलर मोशन करता है. अदरवाइज ये सर्कुलर मोशन ऊपर की तरफ होता अगर पॉजिटिव चार्ज होता. नेक्स्ट क्वेश्चन. A wire 50 centimeter length and 12.5 gram mass is suspended by a pair of flexible leads in a uniform magnetic field of 0.5 Tesla. So this is the magnetic field, this is the mass, this is the length of the wire. What is the magnitude and direction of the current required to remove the tension in the supporting leads? So if we want that, there should be zero tension in these two. So T is equal to 0 here and T is also equal to 0 here. Now for that to happen, what should be the magnetic field or the magnitude and direction of current, right? So give 2 minutes to it and try it out and then I'll discuss. सब छोटे छोटे क्वेश्चन है बच्चों, टिपिकल कुछ नहीं है, दिमाग लगाना है थोड़ा सा. ये क्वेश्चन हल्का सा ही अलग है, बहुत मुश्किल नहीं है, डुएबल है, हो जाना चाहिए. So, अब क्या करेंगे बच्चों? Let us first look at this particular wire. तो ये वायर है, इस वायर के सेंटर पे हमने एक फोर्स दिखाया which is naturally going to act on it, which is mg. Now the mg force was being earlier balanced by these two tensile forces acting due to the two leads or two wires that we have. So now if I assume that these two wires do not have any tension, then this force should be balanced by the magnetic force. And magnetic force on a wire is equal to I L B sine theta. We can clearly see that the angle between the current and the magnetic field is 90 degrees. So sine theta को sine 90 लिख दिया. ठीक है जी. So this becomes sine 90. अब बच्चों सबसे पहले करंट का डायरेक्शन ऐसे होना चाहिए कि फोर्स ऊपर की तरफ आए, मैग्नेटिक फोर्स. तो करंट के डायरेक्शन और मैग्नेटिक फील्ड के बीच के डायरेक्शन में फिंगर्स को अगर कर्ल करूं फ्रॉम करंट डायरेक्शन टू मैग्नेटिक फील्ड डायरेक्शन which is inward, the force would be upwards if the current is in this particular direction. तो सबसे पहली चीज हमने करंट का डायरेक्शन निकाल दिया. अब अगली चीज आती है, हमें मैग्नीट्यूड ऑफ करंट निकालना है. मैग्नीट्यूड ऑफ करंट निकालने के लिए ILB should balance mg. So I is equal to mg divided by LP. So mass is 12.5 into 10 raised to the power 3 kgs. मैं अगर कन्वर्ट करूं into 10 is the value of small g divided by length, which is 50 into 10 raised to the power minus 2 into the magnetic field, which is 0.5, that is 5 into 10 raised to the power minus 1. तो सबसे पहले हम 10 की पावर्स देख लेते हैं. तो 10 की पावर्स में आ गया 10 की पावर 3 plus 1 plus 2 plus 1. ये हो गई 4, 5, 6, 7. सो 10 raised to the power 7 हो गया. उसके बाद हम कैंसिल करना शुरू करते हैं. 12.5 1s are 12.5 4s are. ठीक है ना. So यहाँ हो गया 4 by 5, that is 20. So 1 into 10 raised to the power this divided by 20 हो गया. ये हो गया. इसे further simplify कर लीजिए जितना भी है to get the final answer. But this is how you're going to do the question. So the central idea of the question should be caught. The figure should be, again, emphasis is on the diagram. And after that you see there is nothing difficult at all. अब आता है थोड़ा सा मजेदार क्वेश्चन. थोड़ा सा, बहुत ज्यादा नहीं, थोड़ा सा मजेदार क्वेश्चन. Here I would suggest that you take 3 minutes to do it, and once you've done it, we discuss it. So 3 minutes to you. Bachcho, I hope you are able to understand the central crux of this problem. You have 4 wires. Place them in such a way that they're carrying currents in the same direction, that is outwards. Separation between any two wires is small a. This is how the network looks like. And now I have to look at solving such a circuit. Okay, so let's look at this kind of a question. Pretty simple to handle. बच्चों देखो चारों वायर्स में करंट सेम डायरेक्शन में है, तो if you look at any of the wire, it will be attracted by 3 wires around it. So if I look at this particular wire, it will face an attractive force, or it will experience an attractive force due to the upper wire. It will experience another attractive force due to the wire on this side. This force and this force are going to be same in magnitude, and it will experience a force in this direction, which is, let's say, F dash, and F dash will be different in magnitude because the separation between this wire and the wire here is A root 2, whereas for the other wires, the separation is A. So what is the force per unit length? So the first force per unit length is equal to mu naught. I1, I2 is same, so I square upon 2 pi A. And F dash per unit length will be equal to mu naught I square I1, I2 की जगह upon 2 pi A root 2. Now, if you look at the net force, these are vectors. So forces are vectors. So if I have to find the net force, what am I supposed to do? I'm supposed to, if I have to find the magnitude, I'll say it is equal to F, the first force, which is, let's say, being called small f, and this one, which is being called small f dash. So the net force per unit length, let us call it small f net, will be equal to small f. इस वाले फोर्स का इधर जो कंपोनेंट होगा that will be cos 45, इसका भी इधर होगा cos 45 because these angles are going to be 45 degrees each. So this will be f cos 45 square plus f cos. So वो वाला काम नहीं करते हैं, बेसिकली हमें कंपोनेंट्स ही ऐड कर सीधे हम कह देते हैं कि एफ नेट विल बी इक्वल टू एफ कॉस 45 plus f cos 45 plus f dash. So this is what will give you the answer. So it's equal to 2f cos 45 plus f dash. So 2 into mu naught I square upon 2 pi a, cos 45 is 1 by root 2, plus mu naught I square upon 2 pi a root 2. So mu naught I square upon 2 pi a root 2 तक तो कोई प्रॉब्लम ही नहीं है. यहाँ पर क्या आ गया? 2 plus 1, that is 3. So 3 mu naught I square upon 2 pi a root 2 is the answer. ठीक है बच्चों, सो ध्यान रखना था हमें फोर्सेस का. फोर्सेस निकालने के बाद नेट फोर्स इन दी डायरेक्शन निकालना है, तो एफ डैश वाला पूरा का पूरा हो गया. सो अपना जो एफ नेट आएगा वो इसी डायरेक्शन में आएगा. अगले क्वेश्चन पे आते हैं. A long straight wire of radius small a carries a steady current I. The current is uniformly distributed across its cross section. The ratio of magnetic field at a by 2 and 2a. So एक point, one of the points is inside the conductor and the other point is outside the conductor. So let me draw the figure to help you understand. But again, I would say try it once before I discuss it with you. So this is how the wire is, a long wire. Now I have to find the magnetic field at some point here at A by 2, where its radius is A, and the other point is outside, थोड़ा ज़्यादा ही हो गया, at 2A. So A by 2, A and 2A. तो अब अगर इस केस में हम बच्चों देखें, so A by 2 is inside, so magnetic field dot 2 pi A by 2, this is B dot dl, is equal to mu naught times I enclosed. So we know that I is the current through an area equal to pi A square. So if I have to find the current enclosed inside, it is equal to the current in an area pi A square by 4. So I enclosed is equal to I by 4. So I get B is equal to mu naught I by 4 upon 2 pi A by 2. ठीक है ना? So ये हो गया अपना म्यू नॉट आई अपॉन 2 से एक 4 का 2 कैंसिल हुआ, या 2 से ये 2 कैंसिल हो गया, तो 4 ही आया अपने पास, 4 पाई ए. दिस इज द मैग्नेटिक फील्ड इनसाइड. अब हम दूसरी मैग्नेटिक फील्ड यहाँ पे निकालते हैं, विच इज बी आउटसाइड. सो बी आउट इनटू 2 पाई 2a, that is B dot dl is equal to mu naught times I enclosed में पूरा ही आ जाएगा. So B out is also equal to mu naught I upon 4 pi A. So from here you can see that this B out is equal to B in. So if I have to find the ratio, it is 1:1. ठीक है ना बच्चों? Simple, easy to handle, but diagram should be correct and you should be able to understand what you're doing. अब आते हैं next question. Current I is flowing through a wire loop as shown in the figure. What will be the magnitude of magnetic field at the center of the loop? Each arc subtends equal angle at the center. So each arc is subtending equal angles at the center. You have to find the current, you have to find the magnitude of magnetic field at the center. तो यहाँ पे magnetic field निकालनी है twice capital R और capital R radius के elements की वजह से. So how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are there. And all these 8 elements together subtend an angle 2 pi. So the angle subtended by each element is equal to pi by 4. That's the first takeaway. ठीक है, अब हम एक एक करके मैग्नेटिक फील्ड निकालते हैं. So I'll find one due to the bigger वाला arc and one due to the smaller वाला arc. और फिर दोनों को 4 टाइम्स कर दूंगा, ऐड कर दूंगा, क्योंकि मैग्नेटिक फील्ड का डायरेक्शन तो सेम ही है सबका, इनवर्ड्स. सो मैग्नेटिक फील्ड ड्यू टू द बिगर आर्क, वी नो दैट द मैग्नेटिक फील्ड ड्यू टू एन आर्क, बी ड्यू टू एन आर्क इज गिवन बाय म्यू नॉट आई फाई upon 4 pi r. So due to the bigger arc, it will be equal to mu naught I. Phi की जगह क्या आया? Pi by 4 upon 4 pi 2r. So this becomes mu naught I, and so this is 4 into 2, 8. 8 4s are 32, so mu naught I by 32 r. That is the magnetic field due to one of the bigger arcs. अब स्मॉलर आर्क की वजह से हम यहां से निकाल ही देंगे, बट फिर भी अगर मैं करूं तो इट विल बी इक्वल टू म्यू नॉट आई पाई बाय 4 अपॉन 4 पाई r. So this becomes mu naught I upon 16r. ठीक है ना? So ये हो गया. So net magnetic field at the center will be equal to 4 times of mu naught I by 32r plus 4 times mu naught I by 16r. That's what you have to do and you'll be able to get the answer. Okay. So I think steps are clear. We are doing it this way and hopefully you'll get the right answer after calculation. Further calculation, last step kar hi lena bachcho. I think you can do it easily. अब आते हैं हम next question पे. 3 long straight and parallel wires carrying currents are arranged as shown in the figure. The wire C, which carries a current of 5 amperes, is so placed that it experiences no force. The distance of wire C from the wire D is then. So let's say I take this distance as X. So this distance will be, this distance is going to be 0.15, 15 centimeters, that is 0.15 minus X. Now we know that the central wire C would experience a repulsive force due to D and a repulsive force due to G. So net force would be 0 if both these forces cancel out. Okay, now, so force due to D will be equal to mu naught. I1 is 5 amperes into 15 amperes upon 2 pi x. This is the force due to D. Similarly, force due to G is equal to mu naught. अब यहाँ पे क्या आया 5 into 10 I1 I2 upon 2 pi 0.15 minus X. Now if these two have to be equated, I get mu naught into 5 into 15 upon 2 pi X is equal to mu naught into 5 into 10 upon 2 pi 0.15 minus X. So 2 pi gets cancelled, mu naught gets cancelled, 5 gets cancelled. This is 5 3s are, this is 5 2s are. So we get 3 by X is equal to 2 upon 0.15 minus X. Now cross multiplying 0.15 into 3 is 0.45 minus 3x is equal to 2x, or 5x is equal to 0.45. So x is equal to 0.09 or x is equal to 9 centimeters. So the separation between the wire D and the wire C is 9 centimeters. Simple. इस तरह से हम कैलकुलेट कर देंगे. अब आते हैं हम अगले क्वेश्चन पे. इस क्वेश्चन को पढ़िए. Give it 2-3 minutes. Then you'll understand how to solve it. Okay, so let's look at this particular question. It says a coil in the shape of an equilateral triangle of side 2 meters is suspended from a vertex such that it is hanging in a vertical plane. The horizontal magnetic field of 5 into 10 raised to the power minus 2 Tesla is acting parallel to its plane. Find the torque acting on the coil when a current of 2 amperes is passed through it. We know that torque is equal to M cross P. यानी मैग्नीट्यूड ऑफ टॉर्क हो गया mb sin theta, which is equal to NIAB, and theta here is 90 degrees, so it becomes sin 90. So torque is equal to NIAB. अब कॉइल का नंबर ऑफ टर्न्स 1 है, I हमें पता है कितना है 2 amperes into area. Area of an equilateral triangle, क्या आप सबको याद है? नहीं याद है तो मुझे बता दो. ये साइड है 2 meters, ये साइड है 2 meters, ये साइड है 2 meters. अब काफी तरीके हैं. अगर आपको कुछ नहीं आता तो आप हाफ बेस इंटू हाइट लगाएंगे. ये हाइट आप निकाल सकते हैं. इस हाइट को अगर आप h बोल दें तो ये 2 है और ये एंगल है 60 डिग्रीज. सो यू नो दैट h अपॉन 2 is equal to sin 60, which is √3 by 2. तो h आ गई कितनी? √3. अब आप जानते हैं ट्राइंगल का एरिया होता है half of the base, that is 2 meters, into height, that is √3. तो एरिया आ गया √3. So 2 into √3 हो गया IA इंटू बी की वैल्यू कितनी है? 5 into 10 raised to the power minus 2. तो ये आ गया हमारे पास टॉर्क, और टॉर्क की यूनिट होगी न्यूटन मीटर. तो ये हो गया 10 into 10 raised to the power minus 2, that is 10 raised to the power minus 1. तो ये हो गया √3 into 10 raised to the power minus 1 न्यूटन मीटर. इतना टॉर्क लगेगा. राइट जी, सिंपल एप्लीकेशंस हैं, आप सब कर लेंगे. अब आते हैं अगले क्वेश्चन पे. अ पार्टिकल ऑफ चार्ज -16 into 10 raised to the power minus 18 coulomb. So this is a negative charge moving with a velocity of 10 meters per second along the x-axis enters a region with a magnetic field B is along the y-axis. ठीक है. So magnetic field है along the y-axis and an electric field of magnitude this along the negative z-axis. If the charged particle continues moving along the x-axis, the magnitude of the magnetic field is. अब बच्चों, अगर हमारा जो भी चार्ज है वो मूव कर रहा है along a given axis, it is under the influence of two fields, so there will be two forces. And if the charged particle has to move along the same direction as it was earlier, its direction or magnitude is not changing, its speed is same and is constant, it means that these two forces must be balancing or cancelling out to give you a net zero force. तो उस बात को ध्यान में रखते हुए क्वेश्चन सॉल्व करना है. सिंपल सी बात है. So if you look at this particle, it is a negatively charged particle and you have it moving in this direction with a speed v. There is a magnetic field in the direction that is along the y-axis and there is an electric field along the negative z direction. So electric field is along the negative z direction. ठीक है ना. सो इस पार्टिकल पे एक लगेगा हमारा इलेक्ट्रोस्टैटिक फोर्स, क्योंकि पार्टिकल नेगेटिवली चार्ज है तो इट विल एक्सपीरियंस एन इलेक्ट्रोस्टैटिक फोर्स दैट इज ऑपोजिट टू द इलेक्ट्रिक फील्ड. दिस इज द इलेक्ट्रोस्टैटिक फोर्स Fe एंड इट विल एक्सपीरियंस मैग्नेटिक फोर्स. अगर पॉजिटिव चार्ज होता तो V क्रॉस B यानी पॉजिटिव z डायरेक्शन में फोर्स लगता. अभी क्योंकि नेगेटिव चार्ज पार्टिकल है इसलिए ये फोर्स भी नेगेटिव z direction में लगेगा, opposite direction में लगेगा. तो this is the direction of the magnetic force. And if the particle is moving in this direction, it means the electrostatic force and the magnetic force have to be equal. So Fe हो गया हमारा माइनस की बात नहीं करेंगे, मैग्नीट्यूड्स की बात कर रहे हैं, तो एफ ई हो गया क्यू इंटू ई इज इक्वल टू क्यू वी बी। ठीक है, सो हमारा Q से Q कैंसिल हुआ, सो E इज इक्वल टू वी बी। अब हमसे पूछा क्या गया यहाँ पे, व्हाट आर वी सपोज टू फाइंड, वी आर सपोज टू फाइंड B, सो B इज इक्वल टू E बाय V। सो हम वैल्यूज रख देते हैं, E की वैल्यू कितनी है 10 रेज टू द पावर 4 एंड V की वैल्यू कितनी है 10, सो ये मैग्नेटिक फील्ड आ गई मेरी 10 रेज टू द पावर 3 टेस्ला। सिंपल। ठीक है बच्चों, सो क्यू की हमें जरूरत भी नहीं पड़ी, कैंसिल आउट हो गया, बट हाँ क्यू के बेसिस पे वी कुड फाइंड द डायरेक्शन ऑफ द फोर्सेस एंड वी कुड सी दैट देयर opposite to each other. So for the charge to move undeviated and with a constant speed, these two forces had to balance each other. अगले क्वेश्चन पे आते हैं। This question says two long conductors separated by a distance small d carry currents I1 and I2 in the same direction. They exert a force F on each other. Now the current in one of them is increased to 2 times and the direction is reversed. The distance is also increased to 3d. The new value of force is. So in the first case, this was, let's say, I1 and this was I2. In the next case, what has happened is, let's say, it says now the current in one of them is increased to 2 times. So let's say, पहले वाले वायर में जिसमें करंट I1 था उसे 2I1 कर दिया और डायरेक्शन भी ऑपोजिट कर दिया. So this becomes 2I1. The other current remains I2 only. And the separation is increased to 3 times small d. Earlier it was small d. The new value of force in terms of the old forces. This is what it means. The new value of forces. So you have to explain the new force, or you have to express the new force in terms of the old force. That is what you're supposed to do. So spend 2 minutes on this and then we discuss. So अब बच्चों इस केस में क्या करेंगे, सबसे पहले हम f का एक्सप्रेशन लिखेंगे. So f will be equal to mu naught I1 I2 upon 2 pi t. So f dash will be equal to mu naught 2I1 I2 upon 2 pi 3d. So if mu naught I1 I2 upon 2 pi d is replaced by f, so what is left here? You're left with 2 from here. So 2 लिख दिया और नीचे से क्या आया 3. So this is 2 by 3f. But you know that if I have to write it in vector form, f dash vector will be negative in direction to f vector. So f dash is equal to minus 2f vector by 3. So one needs to note that if I have to report the force f dash in terms of f, so direction का भी ध्यान रखना. One of the forces that we're talking about here is attractive. The other force that we're talking about here is repulsive. ठीक है? ठीक है बच्चों? I hope you are able to grasp and do the questions. Now let's look at one more question. The magnetic field due to a current carrying circular loop of radius 3 centimeters at a point on the axis at a distance of 4 centimeters from the center is 54 microtesla. What will be its value at the center of the loop? सो बच्चों, मैग्नेटिक फील्ड on the axis at a distance x is equal to mu naught I, and in place of r square, what you put is 3 into 10 raised to the power minus 2 square upon 2 r square plus x square. So this is 4 square plus 3 square, और यहां से आएगा 10 raised to the power minus 2 का स्क्वायर इंटू 3 to the power 3/2, यानी 10 raised to the power minus 2 का, पहले तो 10 raised to the power minus 2 का स्क्वायर आया था, उसकी पावर 3/2 की, तो 10 raised to the power minus 4 into 3/2 हो गया, तो ये आ गया कितना, 10 raised to the power minus 6। ठीक है, सो ये हो गई हमारी बी एक्स की वैल्यू, राइट। सो ये कितना आ गया मेरा, 3 म्यू नॉट आई अपॉन 4 square plus 3 square is 9 plus 16 25 into 2, that is 50। ऊपर था 10 raised to the power minus 4, नीचे था 10 raised to the power 6, तो ये हो गया 10 square, right। This is the value of magnetic field at this is the value of magnetic field, right। अब वो कह रहा है कि मैग्नेटिक फील्ड एट दी सेंटर कितनी होगी, बी नॉट जो होगी आपकी वो कितनी होगी। अगर सेंटर पे निकालनी है तो हम क्या करेंगे, इस केस में मैग्नेटिक फील्ड निकालने के लिए हम क्या करेंगे बच्चों, सब जानते हैं, हम करेंगे म्यू नॉट आई बाय 2r, so that becomes mu naught I by 2r, so that is 2 into 3, that is 6 into 10 raised to the power minus 2, तो वो हो गया mu naught I into 10 raised to the power 2 upon 6। ये वैल्यू वो कह रहा है कितनी है, 54 into 10 raised to the power minus 6 के इक्वल है, ठीक है ना। अब ये वैल्यू अगर 54 into 10 raised to the power 6 के इक्वल है, तो अब हमें किसकी वैल्यू बतानी है बच्चों, हमें बतानी है what will be its value at the the magnetic field due to a current carrying loop of radius इतने at a point on the axis, इसकी वैल्यू है 54 into 10 raised to the power minus 6। I am so sorry, we have to tell what will be the value of this mu naught I into 10 square by 6, ठीक है ना। सो हमें ये निकालना है, तो अब आप देख सकते हो यहाँ से इन दोनों को मैं कंपेयर कर सकता हूँ और मैं निकाल सकता हूँ इसकी वैल्यू। तो बेसिकली मैं सबसे पहले इस इक्वेशन को यूज करता हूँ, इस इक्वेशन को यूज करके अब मैं क्या लिख सकता हूँ, राइट। अब आप देखेंगे सो मेरे पास आ गया म्यू नॉट आई की वैल्यू आ गई सीधे सीधे, म्यू नॉट आई इज इक्वल टू 50 into 18, right। So 50 into 18 into 10 raised to the power minus 4। म्यू नॉट आई कितना आ गया मेरे पास, 50 into 18 into 10 raised to the power minus 4, और वो वैल्यू मैंने यहाँ पे रख दी। सो बी नॉट मेरी आ गई 50 into 18 into 10 raised to the power minus 4 into 10 square upon 6। So 6 1 6 3 18, right। सो ये हमारी वैल्यू इस तरह से आती जा रही है, तो ये हो गया सीधे सीधे 150 into 10 raised to the power minus 2, ये आ गई हमारी वैल्यू, काम खत्म, सिंपल। ठीक है बच्चों, सो दैट्स हाउ इट इज टू बी डन। ठीक है. So with this we have completed all types of questions. सीधा फॉर्मूले में पुट करके वैल्यूज कैसे निकालनी है, किस केस में हमें थोड़ा सा और सोचना पड़ेगा, and that is how we're going to do it. So with this I think you would have understood the questions that we've done, and hopefully you would have gained confidence in doing more questions in magnetic effects of current, right? So as requested, next class में अब अगर आप चाहते हैं derivations, तो मैं फिर बोल रहा हूँ कि please mention the right derivations that you want me to do, and I'll definitely take them up in the next class. Thank you. Take care. Bye bye.